All right, so here is the second worksheet you should be working on today. So this one should be titled Relative Dating Worksheet. So make sure you have the Relative Dating Worksheet one in front of you. Okay, we're going over the laws again. So we've got the law of superposition in any undisturbed sequence of strata, which is just a fancy word for rock. The oldest layer is at the bottom of the sequence, and the youngest layer is at the top of the sequence. So the oldest layer, bottom, youngest layer at the top, even though I don't like that. I don't like that it says that. I'd rather it say that the oldest layer has no other layers below it, and the youngest layer has no other layers above it, because that can get tricky sometimes. The law of cross-cutting relationships, any feature that cuts across a body of sediment or rock is younger than the body of sediment or rock that it cuts across. Okay, so let's make sure that we remember these. Law of inclusions. Any one rock body contains fragments of another rock body. It must be younger than the fragments of rock it contains, or the inclusions are older than the rocks which contain them. All right, so let's go down here and let's look. So we've got use the laws of superposition, inclusions, and cross-cutting relationships to determine the relative ages of the following cross sections. Determine the oldest bed first. So we've got A, B, C. Looking at this, B cuts across both of them, so B has to be the youngest. All right, we know that B has to be the youngest. A is sitting here. We've got C. Which one is older? Which one is younger? So let's look at A. A has two little circles in it that look like they contain parts of C. So that means that C must be older than A. Boom. Look at that. Okay, what's our stratigraphic principle? Let's look up here. I would say that it is the law of cross-cutting relationships. Okay, but you could really use any of the three if you wanted to. All right, but I would say cross-cutting relationships. Okay, let's look at number 2. Which one is the oldest? Okay, well, we're pretty confident A has to be the youngest, so let's start with A. That means D has to be this one. We're just process of elimination. That means this one has to be C, right? So then we have to either choose between E or B. Well, if I'm looking at this correctly, it looks like B overlaps E, which means that E had to have been there. So E's oldest, and then B. Boom. Sorry for my terrible writing. It is on the computer, and I'm doing my best with my mouse. So you could, again, use law of superposition there. You could put cross-cutting relationships, either one. For number 3, so let's look at this. All right, we know C has nothing below it, okay, and A cuts through all of these. All right, so I would say C is going to be the oldest. E is the second oldest. Oh my gosh, I'm terrible at doing E's. D would be the third oldest. Now, this is where it gets tricky. Is this an intrusion that goes into B, or is this an intrusion that came out of D, laid itself down like this, and then B covered it up? That's the question we have to figure out. Okay, is A older than B, or is A younger than B? Well, the key is going to be, where does it lay down? Does A lay down on top of the surface of D, or does it take up some of D and some of B? If you look at the picture, it takes up a little bit of both. So that means that A is younger because it squeezed itself in between these two layers of rock. So we're going to put B as older than A. All right, now we're getting into some harder ones because there's more stuff. All right, so let's look at this. We are looking at number 4. All right, number 4. Let's look at it. So the oldest layer, let's start with the oldest. Let's see if we can find the oldest layer first. All right, so we've got this line right here that's M. We've got this intrusion. It looks like that's A because the intrusion goes all the way up here. All right, so just looking at this, we might as well just start with the youngest. So we know H has to be the youngest. And then G, oh my gosh, I'm terrible at writing with a pen, with a mouse on the computer. And then F, oh my gosh, that's terrible. E, and then we have to figure it out. So we've got our youngest layers, H, G, F, E. But what about this line right here? Do you think that, I'm guessing that line would show up before all these other layers got put down, right? So I'm thinking this M has to be right here. Okay, so there's M. But then you notice there's no cut of rock over here to show that A went through the line. But A comes all the way through D, so A would be the next youngest. And then I would say it's layer D, C, and then B. Okay, if you got something different, let me know, but I'm pretty confident that is the order. All right, now let's look at number 5. Number 5 looks like it's a whammy, so let's see if we can figure it out here. All right, so we've got two fault lines. Look at that, 2 of them. There's one here, there's one right here. Okay, so this one's fault line E, this one's fault line B. Let's see if we can figure this out. So I'm going to say because D is over here and D is over here, that makes I younger. I has to be the youngest thing because that's the newest layer that got laid down, right? And then in order for I to get laid down, E had to have happened. So I and then E. And then I would say it's D. And then we got an H here and an H here, so we know it's H. Sorry for my D, that looks like an O. That's terrible. And then, ooh, this is going to be, and then I'm going to say, ooh, man, I don't know. I'm going to say F had to have happened. Okay, look, there's only one F, right? There's A's right here because this is a little bit of A right here. That's a little bit of A. There's an A and there's an A, but F's all by itself. So F had to have happened, and in order for F to have happened, B had to have happened. Then A, then C, and then G. Woo! And I really had to look at that one for a second. Okay, let's come down here. Let's check these out. All right. Outline the sequence of events in the cross sections below by numbering each rock unit or event in the order in which it occurred or was deposited. So the youngest one, all right, well, let's look at this here. So these had to have been tilted up, which means that, oh man, okay. Whew. All right, these really got tilted. So we probably, I would say we have to assume that C is the oldest. And then we've got this little erosion thing that happened right here with B. And then I'm going to guess layer E. D is this intrusion thing that goes all the way down here, and then it comes all the way up here. So it's got to be, I would say, A and then D. Okay, if you got a different answer, mark it down. We can talk about it tomorrow, but go ahead. This is what I'm coming up with, D, A, E, B, C. So if you got something different, we definitely can talk about it. All right, number 7, refer to the cross section on the left. For each of the following pairs of rock layers, identify the relative dating law that would be used to determine which bed was older and which was younger. Circle the letter of the older bed. All right, so you got to tell me how you know. So let's see. A and B. Well, A is definitely older because B wouldn't be there without A. So we know that A is older. Okay, and then tell me why. Let's see. C and D. D has to be older because C has to cut through D. D and E. Well, D would be the older one again. And then J and K. J would be older, right? Okay, and then again, you need to write down how you know. Okay, I'm giving you the answers. Tell me how you know. Okay, this one's really complicated because there's just a lot. Okay, so I might be writing all over this thing. So the oldest layer is going to be this E right here, right? Because H is pointing to the line, so we got to put E over here. And then we're going to have G, and then we got L, and then we got C, and then all those got cut by this line H. And then we've got M, and then D, and then there's a little J right there, so that's layer J. And then look at this. A covers all of this stuff. Look at that. So it's got to be A, and then N, K, B, and then F. Sorry for my terrible writing. Oh my goodness. It's awful. So refer to the cross section above. For each of the following pairs of rock layers, identify the relative dating law that you use to determine which bed was older and which was younger. Circle the letter of the younger bed. So now we're doing the younger bed. So M, where's M? And A would be younger, right? Because A is an intrusion. J, where's J? And N would be younger because N is on top of J. H and C, H and C. H had to have happened because it cuts C. And then what? D and M. D would be younger. There you go. Okay, and then give your reasoning. Why did that happen?